All right, in this podcast, we're going to talk about reaction calorimetry. All right, just to remind you about what calorimeter is, we're basically talking about like a double insulated coffee cup, insulated top, thermometer, stir, and you're putting the reaction, which is a aqueous reaction, in here, and then you're basically measuring the temperature change from beginning to end and seeing what the energy change or the enthalpy of that reaction is. Okay, so looking at an example, we got these 100 milliliter samples of HCl and NaOH, and the following reaction occurs. And then the temperature, which was originally at 23, goes to 28.2. We're assuming no heat was lost to the surroundings. Volumes are additive. Specific heat capacity of the solution is just the same as water's, and density of the solution is 1 gram per milliliter. Wants us to calculate the enthalpy change for the reaction for 1 mole of H2O. So our first step is to determine the moles of H2O that we actually produced. So hopefully you notice that we have molarities of the HCl and the NaOH. They are the exact same molarity, and we have the exact same volume, right? So we can use the relationship for molarity, the molarity equals moles over liters, to determine our moles of our H plus OH minus, which will give us our water because it's all a 1 to 1 ratio. So we have 0.76 is equal to our moles over this, okay, and then we cross multiply, and we get our moles is 0.076, okay, so we need to kind of put that number in the back of our mind. That's how many we have at this moment, and we're going to try to calculate the enthalpy change for a whole mole of them. Okay, so I'm going to kind of tuck that number up here for us. So this is how many moles of water we made. Okay, H2O. All right. Okay, so we need to determine the enthalpy change for what we actually have at this point, right? Okay, so to do that, we know that our volumes are additive. We know that this equation is going to help us. We see we have our C here. Our delta T, which is T final minus T initial, is going to be 5.2. So 5.2 degrees Celsius, that's our delta T. All right, and we're looking for our Q. So we need to find our mass, okay? So if you look up here, we know mass is going to be in grams, and we see there's a relationship between that and milliliters. And we do know the milliliters, right? So we know that we have 200 milliliters, which is 1 gram per milliliter is our density. So that means I have 200 grams. Okay, so now I can just plug all that in. So mass is 200 grams. C is 4.184. Delta T is 5.2. Okay. All right, and I got that. We got this many, and our unit is joules here, right? Okay, so this is how many joules we make for every 0.076 moles of water, right? But we want to make a whole mole of water. So if we divide there, so divide by 0.076, that tells us how many joules for a whole mole. And I got 57,000, and I'm going to go ahead and sig fig this for us. So 57 kilojoules. We'll just go ahead and convert it. All right, so that is my delta H for my reaction. And then it wants to know, is the reaction endothermic or exothermic? So looking at this, you see that the temperature of the solution increased to a maximum temperature of 28.2. 28.2 minus 23.0 gives us our overall change of 5.2 degrees, which is a positive change, right? So it's increasing in temperature, which means this has to be an endothermic reaction. Okay, because exothermics are releasing energy, so they should be getting cooler.